Okay. Okay. As discussed, talking about mappings and alignment. And so some of the what I was just discussing was, how you can enrich, two ontologies, ontology A, ontology B. If there's content in ontology A that's not in ontology B, you can kind of add that information using OWL equivalency axioms or subclass axioms or whatnot. You can also like use disjoint unions to identify basically logical structure that's common across different ontologies. But I gotten to a point where I was saying I bet several of you are thinking, what happens when you're just dealing with two ontologies that are modeling the same domain and they're just straight up in conflict? Like there's just seems like there's no way for you to reconcile these. There's no like common ground between them. Like what do you do? And I made the claim, I'll show you here why, that even in such a situation, you're like you don't have to give up and say, I I can't map these things together. You can. You'll there's a way to do it, and I'm going to show you how. And this was born out of some of these observations, born out of my previous work at APL, but also thinking about like ontology governance, when ontologies are derived from others, when you have to deal with like legacy information. And, I'm fond of this picture to kind of display the trouble space, right? Lots of groups are going to use things like bags of words that they have. Lots of groups use controlled vocabularies, databases, thesauri. We have to meet that challenge head on. Ontologies as well. A lot of groups have their own ontologies. Like to me, the name of the game ultimately is we're going to have to do some mappings at some point. We always will. We want to minimize the number of mappings we have to do. And so instead of having a bunch of different anchors, I prefer this one, this well-developed, like widely used anchor, and like map as much as we can in various ways that we can into like this kind of common structure. Um, Now, it's good for you guys to hear this little spiel I have about application ontology. So when I say application ontology, I don't mean a specific given use or an application of ontology. I mean using an ontology in an application. Like that's what an application ontology is. And that, to me, application ontologies have different rules for like evaluation. You evaluate them differently. Your application ontology might not be BFO pure, but it may also make an application work. And so you had to make some decisions like that adjusted the RDF in various ways so that you didn't it that made you wouldn't want to show Barry, right? But it's okay because that's what you needed to do. I think so. I think questions like how specific should a domain ontology be before it's an application ontology is like kind of a little confused. And now that's a question that I've heard before. Like people would think that a domain ontology or an application ontology is like just more specific. It's not exactly just more specific. It's used in an application, and that's key. And so there are different ways in which you can kind of like really bridge connections across these different legacy structures, different ways in which you can like build application ontologies. I think of adding like enriching ontologies with new content like labels is a kind of textbook example of like enrichment. Um, and this gets to this kind of overlay file point, gets to what I was mentioning a minute ago about like configuration management. Like you say ontology A made a distinction that ontology B didn't make. That means, if you want to connect them, you should add something to ontology B that there's a hook that ontology A can get into. You don't want to necessarily change ontology B, but you could create an overlay file, I'll call them, where you just kind of have the IRIs that you'd need from just the IRIs. You don't even need the annotations and everything, just IRIs that you'd need to make the connection between ontology A and B. And then you can just import that overlay file whenever you need to make those connections. You can just bring them all together. One of the beauties of having IRIs is they will resolve together. So it's a unique identifier. So if you have IRI like 1, 2, 3 in ontology A and IRI 1, 2, 3 in ontology B, and you bring them together, they are the same. They're picking the same thing out. So that reference is connected. And so overlay files can be distinguished. Like you can create all sorts of overlay files that don't really change the ontology per se, but can do things like add labels, right? And maybe you want a bunch of labels in an overlay file that you don't want to go in BFO. maybe BFO, you want a Portuguese version, or maybe one with all sorts of alternative labels, but you don't want to put them in BFO proper because you don't want to push that out to the whole community and be like, oh, great, I got Mandarin everywhere. You can create a Mandarin overlay file, Portuguese overlay file. That's an application, right? Uh, for example, like, and you might need something like that if you're doing like some NLP-based training. Labels, like NLP eats labels. They love it. Like, add more labels. Maybe you don't want to put all that in the ontology proper.
Hey, John, I have a question.
Yep.
So there's some ontologies that, can go into BFO rather easily. Obviously, you guys worked in core with Provo and did a Provo mapping. And then there's some other things that just are massive headaches like FIBO, right? But what if you have some, and then there's things like maybe what UMO or the one that Guzzardi does where they've used Pendurance and Endurance. So that might be an easier mapping. But what happens when you need to bring something in and you're like, this is built in a way that is not, I just can't use BFO. Like,
He's getting ahead of me because this is literally it's like you're a plant, Jay.
but okay, so actually, this is actually really good because I'm in real world situations trying to make money, having these debates and these problems and these questions. So when John is showing this in class, he's not just showing it from like an academic perspective. This is like real world ROI stuff. So, all right, I'll let you go since you're going to go there.
And I'll say, like, so after I gave this talk, I got a bunch of people walked up after me and they were like, oh, dude, what? I didn't know you could do that. Like, John Vita actually walked over and he goes, hey, man, you didn't teach us that in class. I said, I got a few tricks. Oh, but it's because what I'm about to show you gets right. I think it gets right at the heart of that problem. Like, there is this suspicion that there are structures out there that just cannot be mapped together in BFO if you have this one architecture. Like, how exactly we're going to be able to accommodate that? I think there are ways to do it. I think, you just kind of have to lead into the problem and think carefully about the difference between application ontologies and, like, ontologies in a pure sense. Because
I agree, John.
I'm going to illustrate
When
that
somebody
right
says
here.
something is something in another ontology,
Mhm.
it already has a different IRI. So
Mhm.
therefore, it's not the same IRI as what you have. So just because somebody calls something, say, an organization in another ontology, that's not the same as
Right.
CC's organization.
That's exactly right. It matters what the semantics are. So this is how I illustrate the point. So you've got on the left-hand side BFO, like a portion of BFO between entity and specifically dependent continuant. And then on the right-hand side, you have a made-up military artifact ontology that is terrible. It's a bad ontology. Look at this thing. We've got an operation area is a subclass of a ground vehicle. Okay. What? That's crazy. Uh, yeah. So you'll have you now. This is not. I didn't pull this from a real case, but I've seen stuff like this before. Just like confusion. There are many ways to address this. You could go talk to the SMEs. You could go try to figure out what they meant. Maybe they meant some. I try to be charitable, but maybe you don't have access to them. Maybe you can't change things. Maybe it's doctrine. That's kind of the question. Like, how do you address this problem? And you have one kind of architecture that you want to use, BFO. How do you do this dealing with legacy? Here's a strategy. You take the got a question over here. See, look at that. Austin's being charitable. He's like, yeah, there's an interpretation. Love it. So here's a strategy that aside that I'd advocate, just mostly to highlight this, but I say it mostly to highlight this. I did this with a wildly different ontology than BFO at APL, and they were not they were as divorced as like BFO and FIBO, which I know you probably don't know FIBO. This is a finance and business ontology, so wildly different structure. I did this with something like that, and I'll show you how we got them to sing together. So basically, it's just a highlight. I just kind of moved the classes on the left-hand side. I like just plug them in where they would go in BFO. Just drop them in. Like military artifacts are objects, like ground vehicles are objects. Flight path is a site. Operation area is a site. So there was that. Oops, doing that. just highlighting how I move some things around. Still, observe, they are not the same. Like they're not the same just because what I've done is I've broken up that right-hand side of hierarchy and put it into places where I thought it would appropriately go in BFO. So they shouldn't be the same. I've not like just taken that bad hierarchy and made a bad hierarchy in BFO. I put it where the stuff was supposed to go. Here's one way, my preferred strategy for making like getting these things connected. So I introduced an object property, links instances to instances called I called it military taxonomy. And it connects the instances of one ontology to those of the other. And I simulated effectively, I simulated the subclass relationship. So in ontologies, you have like continue or material entity is a subclass of independent continuant. What that means is like any instance of material entity is an instance of independent continuant. That subclass of relationship, it has role constraints. Like you'd see, you know, like there are role constraints you'll see in Protege, like functional, symmetric, stuff like that. There are specific role constraints that govern subclass of, namely that it's reflexive and transitive. So anything is a subclass of itself, and there's a chain of subclass. And if A is a subclass of B and B is a subclass of C, then A is a subclass of C. That's kind of characteristic of subclass of relations. So I saw that, I knew that. And so when I was dealing with this problem, I was like, I'll just create a simulated subclass of relationship. And then I used the only clause. So I said anything from this class, and I use this to like connect like the classes, like those bad classes that I'd added in BFO. Then when I've just done the placing over, I have the classes they shouldn't be connected to in BFO, but were connected to in the taxonomy. Hold on, let me get through this because I think I might be able to address some questions from hands. So reflexivity just relates every instance to itself. Transitivity, just like I said. So here's what it looked like in Protege. Military artifact taxonomy is related only to aircraft. So what that means is flight path, even though flight path is a direct subclass of site and BFO, this says every instance of flight path is connected through military artifact taxonomy to only something in aircraft, where military artifact taxonomy is reflexive and symmetric. So it's essentially subclass. So I basically just simulated subclass and then connected flight paths to aircraft, because in the original taxonomy, flight path was a subclass of aircraft. And so you can see the kind of connections here. Flight path connected just through that. And then I've asserted that restriction in the BFO file. And what this does is essentially, hey man, this does essentially, if you put these together and then run a Hermit reasoner, hey man, then you'll get this bad taxonomy, an inferred hierarchy within BFO, the BFO enrichment. Now, everything I said earlier, I asserted, like flight paths is a subclass of site. That's still here. But now I've also reconstructed through inference that bad taxonomy within BFO. Now, so one thing you should note is like, oh, great. Like I could just use existing tools, knowledge of a little bit of logic, and infer information and like the taxonomy that I was accustomed to without kind of like breaking BFO, even though this was bad taxonomy. Here's the thing. So this only works because I asserted a disjoint, like I dropped disjointness on some of the classes in BFO. So in BFO, site and object are disjoint. You can never have an instance as a site and an object. So operation area can't, strictly speaking, be a subclass of object and an infer class of site. That's fine, because this is you would use this when you would use this is in an application. They have different rules, and I use this in an application. So I tell you what the application was. We needed to be able to generate a visualization of this alternative perspective on the world and BFOs. We needed to be able to give users a way they can toggle between like flipping perspectives. And this is a very easy way to do that. Like you can just generate the hierarchy within Hermit, push a button, boom, it presents it. Now, most importantly, to me at least, it's not just about visualizing in GUI or something, but most importantly is like now I know formally exactly where those structures differ, exactly what I'd have to drop in BFO to make them work. And that is something I continue modeling. I continue tracking. Like, where do these things differ? Disjoint with between these. I have to give up something. And that's how what I have to do to make these two structures work together. That is very valuable information. So I could bring that back to them and say, you're conflating these two. Or I could just, worst case scenario, just say, if in different applications they get a result that's different from our result, I can explain why. Because there's this thing I can look to and say, they don't draw this logical distinction that we draw. And that's a lot easier to swallow than just looking at their taxonomy and saying, boo, I don't like it. Like intuition mongering. Intuition is fine. Like we were doing it a minute ago. That's why I used that example. It's like operation area. Come on, like that's a material artifact, sure. But now I've essentially got a proof I can provide and say, here's exactly why I think, not just intuition mongering, but there's like a logical distinctions being drawn here that they're not doing. So in a sense, worrying about like how do we map things together when they're incompatible. In a sense, there's a lot of work you can do mapping them together. And like depending on what your application is, you might not need to use disjointness. Depends on what you're doing, right? You could still do like a lot of simulation like that. If you need to use disjointness, you need like real rigorous enrichment, like logical enrichment across these mappings. There may be cases where you just can't bring them together, but you'll know exactly why. And I think that's not just, I don't think that's just like cool. I think that's desirable. I want different perspectives on the world, and I want to know exactly why they're different. And this is like a strategy for making it clear where exactly they're different. I'll pause now. So there's some more, but I'll pause if there are any questions.
John, but yeah, question, Tim here. Why isn't their application ontology just considered wrong,
Yeah.
right? And rebuilt? Seems it would be easier just to bring it over,
Mhm.
right? Formalized. I mean, I understand the use case of FIBO, right, where it's more complicated. But in your example, it seems it was just a bad ontology. Why not throw it out and start over?
For this one that's so simple, like I made it simple to highlight the mapping, but the one I was working with was a lot bigger. And in some case, and like there's some reasons like I had done an assessment of this other ontology and provided a cost to the sponsor for how much it would take to just make it a BFO. And they were like, oof, that's a lot of money. And but it was actually easier to just do this mapping. So there's one. Also, we don't always have the opportunity to make changes like that. Sometimes like things are like representations or structures are hard coded into software, just hard coded in legacy, and they're not, maybe because of doctrine or maybe because of governance, they're just not really easy to dislodge. And we still want to make some inroads if these groups are wanting to leverage ontology work, to kind of like support them as best we can. Ultimately, they should fix it, right? But and to me, I feel like this is part of you know a way forward to both showing them that we can provide some help, even if they're not ready to make that transition. But if they are ready to make that transition, I can tell them exactly where to look, like debugging wise, look at disjointness.
And this is only used in a situation when you're mapping something that
Hmm.
is a disjoint that you're going to be using. So if you're just out there in the GitHub world looking for things that you could use and you find something
Hmm.
and it's just you're building your own application
Hmm.
and you're not going to use their stuff and it's not going to go into other systems that they're using, you don't have to do this. You only really have to do this when you have a customer that says, "Oh, we have this whole thing over here. It uses this. We have the map into stuff we're going to use over here. That's going to use what you're building."
Hmm.
Right, John?
Yeah. And I mean, I think those cases are, they're not that common. But I think what is common is the concern that there's some structure being used and now we're imposing a new one and they have to change everything or they can't use this at all. And so part of this is mitigating that intuition. Like we can do what you can do. Like I've shown this to sponsors and they're like their heckles are alleviated. They're like, oh, okay, I'm not that worried. So part of this can be used as a marketing strategy. So Tim is asked why I introduced taxonomy object property because it doesn't have all the same implications of subclass of. Which ones do you have in mind? Because it should have all the same implications of subclass of. It's the same formal relationship.
Oh, okay. Yeah, I think I just missed. So then why not use sub or why use that one?
Subclass of is a part of that reserved vocabulary in RDFS and RDFS and OWL. And so it has like it's kind of hard coded into tooling. And so I couldn't easily like get access to it without like, especially if I was trying to highlight something in Protege. So I just couldn't get to it. But you'll actually see some groups do just that. So like I've definitely seen people introduce a new object property called RDFS subclass of, and they'll say it's reflexive and transitive, even though it's built into the way like Protege displays and the way like top grade person displays stuff. But this case was more like how do I get access to that relation? I couldn't figure out an easy way to do it. And so I said, but that's fine. I know how to simulate it anyway. And so I'll just display it. And
But
also the better work of like highlighting exactly the relationships with a different object property.
but um is it because you don't want to cha actually change the hierarchy
Mm.
or because you can make, you can make these subclass relationships, um but I guess that would be changing the hierarchy, or I'm just not following the
Yeah, I think part of the like the way that the taxonomy is read, like I'm asserting, like in Protege, for example, you make these subclass of relationships and you don't really assert it. You just kind of like plug little classes under other classes or representations of them. And then they get the subclass of interpretation. So they have like the transitive and reflexive stuff. And then you add constraints onto those, like object property constraints of various sorts, and then you run a reasoner and you can get like you can get an inferred hierarchy that could be slightly different or majorly different from that asserted one. But the subclass of and like constraints hanging off of classes, that's like part of the assertion, the asserted hierarchy. And so for that, like I mean, if I were to try to like make the like just drop in the kind of like bad taxonomy into BFO as
right.
subclasses, I'd still have this problem of like just asserting, like straight up asserting that this taxonomy is a BFO taxonomy, like, and that's I mean, ultimately, I've inferred something like that by dropping disjointness, but I'd have to like drop an assertion of disjointness like in BFO proper, you know, and I wouldn't be able to like recover BFO at all. And so at least with this kind of, there's a clear line, like to my mind, and maybe there are different ways to do this, better ways, but like to me, there's a clear line between like I can see and visualize this clear asserted hierarchy that is in a BFO sense right, you know, but then I can see their inferred hierarchy that is in a BFO sense wrong, and that there's like a button I push that shows that and a button I stop pushing that shows the former. Although formally, I'll grant maybe this is where your thoughts are. Formally, like I could just assert, right? Like you can carve this up in different ways. I know for this application we're working with, I wanted to be able to see a clean taxonomy and then the messy taxonomy, and I wanted a quick way to push a button and make those pop up. But again, you could do this in a couple of ways. I'm always open to other
Right.
ways as well.
John, what if you I think one of the things is important is to know how they're using it, right? If they're using the taxonomical structure in their application, but if they're not, why don't you just eliminate the subclass of structure,
Mhm.
turn it into basically an OWL version of a controlled vocabulary, and
Mhm.
then just rebuild your subclass of structure into it from BFO?
I mean, yeah,
I mean,
depending.
it depends, right? I mean, it doesn't depend upon how they're using it.
Mhm.
Because
Mhm.
if they're really only using it as a tagging system,
Sure, right.
right? Like a lot of places do. And
Mhm.
what I've noticed, and I've tried to show this to some customers, is like not everything that's in Turtle or RDF-XML or says it's OWL is actually an ontology.
Sure. Yeah.
Sometimes you're just models. I mean, sometimes they just have things floating and,
Mhm.
yeah.
Yeah, no, that's fair. I mean, this is absolutely true. Like different groups will, and you could see this in what I've presented here. Like different groups are going to be fine with dropping disjointness because they don't care, right? Like that's just not what they do. They're just doing tagging or something like that. Other groups, I've encountered people who are like, they care very much about dropping disjointness, right? Like it's like I would never do such a thing. That's giving up the spirit. And it always depends on what application you're thinking of. Like, does your application need all of the logic of BFO? Does it need some of the logic of BFO? Does it just need a class structure? Does it just need annotations? The weaker the semantic need, the easier it is to map things together because you've loosened up the semantics, like because you need less of them. And so at some point you just like IRIs and IRIs, right? Like, and or maybe just annotations and annotations. But if you want to do to my mind, the kind of rigorous enrichment work, you get down into the logic, right? And I can always construct the other stuff out of like the formally rich logic. Can't always construct just out of annotation properties, disjointness, right? And this was part of that talk, right? I was like emphasizing build the semantic like rich structures, even if you have to map them together like this, because you can always pull it off, like pull off whatever you need to make two things sing together, these structures sing together. But it's really challenging if you're just like, if you don't have the enrichment, because you don't always have the time to go talk to the people who can explain to you what these structures meant. You can't leverage machines very easily to integrate them. Like they you're just setting yourself up for failure long term, or at least more work long term. So I always emphasize again, I'm a build a model of the world kind of guy, semantically rich model of the world. So I can simplify it easier than I can go and if I go with a simpler model and try to build an enriched one. So
And John, what do you lose when you go from say L2DL to L2RL?
uh let's see. I don't know that I can answer that.
Because I
But
know a lot of large graphs.
yeah,
They rather use two RL because it's
yeah.
quicker, right?
And you're
But
using some inferencing power for sure. The same with like elk. But this is I'm gonna pause on that one because I wanted to show you guys something else. Because this is matching and mapping, right? And I think mentioned some of these slides. But I wanted to show you something I think I didn't show you yet. So this is what I'm going to show you here, the semantic alignment. There is a way to like create SPARQL queries to do that checking I was drawing on the board, like the graph structure checking. And it trades on this theory of bisimulation from formal logic that allows you to show basically when two graphs match or counterexamples to those matches. And I won't go through all this nonsense because it's easier to just visualize, but here's like the formal characterization from John von Bentham, who wrote about this in his dissertation, which is like mapping modal logics to one another, which actually have an interpretation and description logic. And so so I just mostly just want to show you, okay. There are, as I hopefully I mentioned, OWL is the web ontology language. It's modeled on a very expressive description logic. Description logic is like a family of logics. There are lots of different description logics, and these description logics come in different strengths. They all have the characteristic that they operate over a finite domain. So there's not an infinite number of things in the domain. And also they only have at most two place relations, so no three place. And this is because description logics that people want to keep them decidable. So any question, you can always get an answer, true or false, to anything you assert. Like, is it really entailed by your theory or not? It's decidable. And more expressive languages are not. And so we want to kind of stay in the OWL community. We want to stay in that space. And so, but again, there's like a lot of ways to create languages that are decidable. So kind of the base language we have is like this attribute language concept, I think, ALC. It's like the minimal description logic. There are like enriched versions. This can only do so much. You can only like you can only represent like all, some, like everything, relate like simple instance to instance relationship classes, stuff like that. So it doesn't have a lot of like too much power. Again, it's just kind of a basic syntax for this. Now you might now if you're thinking, if you're thinking at the level of language, it's like ALC. I want to add, something to it. I want to add like enrich the syntax and the semantics so I can say more stuff. There's a question of like, if you've added something to ALC, like have you really created a new language, or have you just created like another way of talking about the stuff you already have? Because there's a real that happens, right? I'll give you an example, like set theory. So set theory, it's about like like sets related to sets, right? Like subset and all that good stuff. There's like you can define a subset of relation, like this is a subset of that. It's very similar to subclass of, right? Subset relations can be defined in terms of this kind of primitive membership of like this thing, this number is a member of this set. This pen is a member of this set. And you can use that to create a definition for subset of. So say adding subset of to your language of set theory doesn't really add anything new. You just kind of put an abbreviation on something you could already do. So that's what I'm talking about. Like when you're thinking about like expressivity of languages, it's like, I can add stuff to talk about new stuff, in new ways, but have I really added anything new? Or have I just added an abbreviation for something that I could already talk about? So there's a way of understanding this kind of relationship where it's like, how do you prove a negative? Like, how do you prove you can't just decompose this new thing into stuff or the ways you could already talk? How do you know, putting it in the set theoretic terms? How do I know that I can always like decompose subset of into membership? Like, how do I know that? It's supposed to be if it's a definition, I should never be able to find a counterexample. I should always be able to decompose it. So the sense in which this is like you're trying to prove a negative. How do you? And so that's traditionally a big challenge. And so John von Bentham like came up with a kind of graph-based by simulation strategy for proving stuff like this. And so I think it's easy to see. So this is a complicated, not too complicated, but an expression that you might see in description logic. And it basically says something along the lines of this class has your class has some like, or yeah, any class, like if they're thinking about this as like a graph, like think about that expression as a graph. And it's basically saying there is a male who is a parent of a male, who's a parent of a male and a female. And that's what the M's and the S's are. And so there are a couple of ways in which you could draw a graph that satisfies that. So you see on the right kind of the simplest way. But the graph on the left also satisfies that because it doesn't say like you can't have more than one, right? And so so there's this question like how do you, and this is the first order, like just spell it all out. And here's the kind of natural language. Any X that has at least one son, who has at least one son, it has at least one daughter, stuff like that. So you can kind of paraphrase this out. Now, how do you, but like, so both of these graphs satisfy this expression. How do you tease out the differences? Because if you just have kind of the ALC language, that minimal language, it can't distinguish these because it doesn't draw appropriate distinctions to do so. You can add though to the language, and a lot of people do, inverses. So ALC becomes ALC1 or ALCI. And what inverses are is it's a way to say if I have an object property R that relates X to Y, I can introduce an object property R, -1 that relates Y to X anytime I have X to Y. So any R or X R Y, I can assert an inverse YRX, right? And that you have to assert that because, and one of the reasons why you have to assert that additional machinery here is because you actually can't just using ALC like construct or define inverses. You literally have to add some new semantics, something new. And you can see that because it can't distinguish those graphs I was just pointing to. And here's here's kind of an illustration of how you would show this. So, and this is the bisimulation walkthrough. So let's say you have these two graphs. One is very small, E2. One is a little larger. D1 is related to D2. So there is a bisimulation between them. And what this means is that D2 is a member of, the class set D on the left-hand side, like the model, just in case E2 is in the domain of the other alternative. So these D's here, like the capital D's, these are like the respective domains of these. So DI1 is like the set of all instances that you should expect to see on that left-hand side, D1, like in that model. Like those, there's all sorts of instances. So like D1 isn't there, D2 isn't there, right? E2, that's in the set of DI2, which has all the other instances. It could have many other instances. Right now, we're just saying it has like E2 in it, but it could have all sorts of things. So these are two separate domains. And what this is saying, we're asserting is a bisimulation between D2 and E2, which means, E2 is a member of that domain, just in case E2 is a member of its own domain. But D2 is also a member. What this says, D2 has an inverse, basically. So without getting into the machinery of the language, that assertion I've made is D2, there's an inverse of it. It's the object property that goes the other way. There is no object property that goes the other way for E2. So putting this in a different way, you can distinguish, this should be very intuitive. You can distinguish these two graphs. Like if you just focus on D2 and E2, you're just looking at those and thinking about what does D2 point to, what does E2 point to? As far as you're concerned, they're the same thing, right? But if you can also say something points at them, now you can distinguish them. ALC, that base language, can only talk about what D2 and E2 point to. It can't talk about what points to them. But if you have an inverse added, you've asserted that you can have inverses, like in ALCI. Now you can also say, well, I can distinguish them based on what's pointing to them. And so that's how you can draw a distinction here between like the expressivity of in a language with inverses versus one that's not. You just kind of like, you can bisimulate. Like I'm just looking at ALC, D2 and E2 are the same. But if I'm also looking at if I'm looking at it from the perspective of ALCI, then D2 and E2 are not the same because something's looking at D2 and nothing's looking at E2. And here's like a proof and all that good stuff. There's another example. This one goes back to that original one I was talking about with sons and daughters. And so, here I can show you that these are not the same. And it works just like this. So D1 and E1 are both instances of male in this case. So far, so good. You always want to check that. You have to have the classes, the instances linked up to the right classes. The bisimulation proofs, because Van Bentham is very playful, he calls them the zigzag strategy. So going one way is zig, going the other way is zag. So because, as you'll see, we'll draw a Z like here. So what you do now is after you've started at the top, you work your way down. If one role relates D2 to D or D1 to D2, then there's a map from D2 to D2 to E2, where D2 and E2 are both instances of M, and from D2 to E3, where D2 and E3 are both instances of M. So this is like I've mapped from the top and said, okay, are these the same? You go down to the next level and say, do I see the same structures from here to here? Now, it's not saying, do I see exactly the same structures? Only one. Like, it's not saying that. It can be two. That's fine. And that's what's going on here. But you also have to be it also has to be the case that E1 is mapped to those, right? So far, so good. They've got the same structure as far as like we are moved through the tree here. Now you go to the zag. So now looking here, if this role, see, it's the object property role, if it relates D2 to D3 and D2 to D4, zag, you got to go back. Then there's a mapping from D3 to E4 and from D3 to E5, such that D3 and E4 are instances of M and E5 is an instance of F. Okay, so we've got a break here. So because I have to have C related to these things, right? So if these were really isomorphic, then E2 would have two things hanging off of it. E3 would have two things hanging off of it, but they don't. And that's because D2, the reason is because D2 would have to have, I mean, it does have two things hanging off of it. So fundamentally, there's a structural difference between them. Does that make sense?
You need ALC with inverses to be able to solve that.
Yeah, you've gotta be able to like look back up, because when you're evaluating the instances, you're like evaluating it like, what do these arrows point to when you're in ALC, and not what's pointing to them, because ALC can only kind of look forward.
So if you just ran regular ALC over this, they would say that
They'd
there's
be like, look, you got the same structure. Yeah. It'd say that it can't distinguish them. Yeah. I won't go through this one. What I will point to though is that there's research on this topic that outlines how you write SPARQL queries to check bisimulation. And they're not hard to find. So you can write SPARQL queries that will absolutely check to see when two graphs are bisimilar. And it follows the zigzag strategy. And in fact, there is a paper I'm quite fond of. I'll try to find it and send it to you, that kind of writes queries that trigger the zig and the zag. You can see it operating. We got some questions. Let's see. Johan von Mental. That's good. That's good. Thank you, Sam. Very good. Okay, so right, what I've just showed you is sort of, I mean, it's not sort of, this is cutting edge, right? So I'm trying to show you guys stuff that is not widely known, not widely discussed. I want you guys to be on the edge. And so the stuff about like the mapping, using OWL to map ontologies together, I'd like to see that. Not a lot. I mean, there's a lot of work on mapping. It's not good. I will say that and post this on YouTube. It's not good. I'm not a fan of the work, and I'm not impressed at all. I think what's needed to make the mapping working make sense and useful is exploring like how you build logical relationships, how you unpack and how you track differences in semantics. So that disjointness stuff is a good example. But also, how do you prove mappings? And how do you prove that two things are structurally the same, but not having you sit around as researchers and like thinking hard about it, but how do you say write code or write queries that can do this kind of checking for you? That's a novel territory for two reasons. One, I just don't think there's been enough research poured into thinking about the actual logic underpinning these structures. And two, because of that, perhaps even less research on how you would automate the checking of these things. And so, despite the fact that it probably felt like Sean was going on a crazy ass tangent about wildness, this is very much related to the mapping stuff. Like this is a improvement on existing work, and by redirecting, I think, into a novel space where there's plenty of new research to do, and you are now, as far as I'm concerned, on the edge of where that research is, because I don't know of anybody else has been thinking about it this way, although I hope everybody starts thinking about it this way. So I'm going to pause there. I didn't expect to be talking so long, but when has that ever stopped me before? I'm all right. Questions, comments, concerns, compliments. I'm going to take about it.
Send that slide deck out when you send out that paper, when you find it.
Yeah, man. Absolutely.
Cool.
I'd say
Yeah.
there's a lot to digest there. I
Yeah.
have to think about it. I need to
Yeah. Yeah.
So John, one of the things we also have to realize is that, RDF or OWL is monotonic, right? So when we have um, negative relationships, they really don't handle that. That's why we use inverse properties, correct?
Not quite. OWL has negative object property assertions, right? So you can say something that's not related to something else. So there's that. But it's there's an allowance for defeasible reasoning, even if there's monotonicity. So in traditional logics, just because if you don't say something, it's assumed to be false, right? And so that's not the territory we're in. Just because you haven't said something doesn't mean anything. You could just not know. But so there's some like defeasibility built in because you're not like pigeonholed into saying, asserting something you didn't intend to assert. But yeah, in any event, like you can assert like negative relation. Like I can say that John has not seen his cat Otis. So it's their instance. I have not seen Otis. I can't say that I haven't seen a cat because that's a relationship between me and a class. And you in OWL 2 DL, you can't do that. That gets into the undecidable territory. But so there are various things you can do about that. But like, yeah, there are some cutoffs, of course, in what you can express. But yeah. Anyway,
I
hopefully
think what you said right then was even key for people that are modeling, like who haven't modeled a lot, where like just because you don't say something doesn't mean it's not true or doesn't exist. And I think sometimes we get caught in this universal modeling and we think, well, I can only model at the instance level if I model at the universal level. But then, like, no, because if we did that, our universal model would just have so many existential sums. Like the fact that you can be friends with another human being doesn't necessarily have to be modeled at the universal level to have a friendship relationship exist between instances.
yeah, right. Yeah, that's right.
How many really successful mapping projects are there?
I know of two. So it depends on what you mean by really successful. I know of one, and that's the one I just showed you because I know what happened with it. It was very successful. It can I say it really highlighted well, I don't know how much I could say, man. It took the teeth out of an opponent. How about that? Let's say there was like a rival to BFO, and there was like not concern that they were just loud, and I may or may not have been tasked with John figure out a way to make this a moot issue, and so I was tasked with like solving this entrenched traditional problem in the community. Like you got these two warring ontologies, people are fighting over the representations. How can we make progress from like an engineering perspective and like make, kind of take the teeth out of this particular debate? So this debate that's gone on for like 30 years, how do we do that? So this is what I came up with. And so it was a mapping strategy, and it worked like gangbusters. The teeth were gone from the dispute. And then it became a question of, okay, why use BFO as opposed to this other thing? Well, there are plenty of other reasons, like disambiguation, 700 plus users in the open space. Like it just became like the kind of like intuition mongering that you would see at like a top level. Like, oh, perdurance make more sense than continuance or occurrence, right? That kind of like, I think untrustworthy, bad faith, our dispute was no longer an issue, right? Which I thought was good because I don't care what most people what their intuitions are about continuance. I don't care if they sound weird. Like, what do your intuitions have to say about this? This is like high church metaphysics. I, or it's like ontology engineering. Like, so we shouldn't be arguing at that level. So this strategy helped us, I think, focus in on what was more important, which is like the applications, getting out deliverables, and focusing on like the kind of content that we could leverage that already existed.
Isn't that the most important thing really with adopting a TLO? Is that now you don't have to really argue for building your own TLO and argue all of those kind of almost metaphysical things like what is a continuant and what is an independent continuant and what is an occurrent and what is the difference?
I
And it
think
lets you
it's-
get on to actually production.
Yeah, right.
Yeah.
Yeah. I mean, I see the striking analogy between that, like ontologies at the top level and programming languages. I'm sure you've heard me say this. There's, of course, differences, right? Ontologies are not programming languages, right? And like sometimes there are great reasons to use C++ rather than Python, of course, right?
Yeah.
Fortunately, we have never as a community gotten to that space. We have never gotten to the space where, well, what application driven, like deliverable driving questions should we ask on whether to use UFO versus BFO? We've never gotten there. I'm hoping that we get there because I think they're probably good reasons. But I don't to choose one or the other for different applications. I have no idea what those would be. Let's go find them.
I think that's why Guzziardi wants to work with me on this project because
Yeah.
we're going to have to get there. But it's sort of like with an ontology, where with an applied ontologist that's working in the field, it's sort of like we don't want to get into these sociology debate questions. We're like literally trying to help a patient. We have a patient come in our office for a psychiatrist, and they're like, "I don't want to kill myself." Okay, I want to prevent you from killing yourself, but I don't want to get bogged down into like what Kahneman said 30 years ago. I want to help him.
There's like a joke here about, have you heard the good news of BFO? Like, oh, you're suicidal. Let me preach to you now. uh, but yeah, no, this is right. We don't want to have those bogged down conversations. We want to focus on what we can engineer.
Question, will there still be some space to ask some questions about project 3?
I was just about to pivot over because I absolutely want to talk about project 3. Yes, by all means, let's just run in. Let's do it. By the way, feel free to take a break if you need. I always forget that, like, feel free. If it's okay, I'll just keep talking. But I'll try to fill, if anybody leaves or something, I'll try to fill you in on what we talk about. So, but I'm sorry, go ahead.
Well, I think this I'm really trying to come to grips with what is this mapping thing exactly accomplishing, etc. And I think a lot of interesting questions come out anyway for myself, but it also up to a degree that I say, yeah, how useful is this? And I think Joshua mentioned that sort of why not collapse it back to something primitive, if you know. But let's put that discussion aside, because what I saw with IES was sort of like, okay, there is an ontology. There is some weak axiomatization going on. And because BFO is more strongly axiomatized, if I want to be able to map at all, intuitively, at least they have to have the same level of axiomatization. But then I'm really sort of putting the way of working of BFO onto IES. And I think sort of having strong axiomatization is sort of a good thing because it sort of makes explicit, I think, what otherwise people will do implicit.
Yep.
But still, I'm going to come in and say like, yeah, your weekly your axioms are weak. We need to prop them up. And the second thing rolling forward is then, for example, there is this example of an event, and that might be a process. And then I'm sort of, what I would like to say then is, so maybe you wanted to say something like, there's other things taking part, and maybe there is an event has a sub-event, yes or no. So you need to tease all these things out before you can make a mapping. And the question then arises is, am I actually going to add these axioms BFO wise? Like, if I'm saying we're going to play the BFO game on IES, because that's basically I'm moving in that way.
Yeah.
Then I'm sort of also tempted to say, yeah, let me sort of add then sort of some BFO stuff to IES. I mean, that at least I can express it, and at least my mapping algorithm will be helped. I
Yep.
mean, there's probably all kinds of things go horribly wrong, but one of the dilemmas I had was, do I then go adding things to IES, or is that then that overlay thing?
Yes.
And okay, and I only use terms from IES to mimic BFO. I mean, that's then the game I'm going to play. And so if there is something like, there is no object property for this event has, or participants has these entity participants. If that property is not there, I put it in the overlay. Sort of like, we need that at least to disambiguate what you're saying.
Yep.
Sorry about that. And
Yep.
then you progress.
That's right. I feel like you've got it. So like the only thing I'd add is that the addition of the axioms, it's not just throwing BFO on top of them. Like, it has to be justified to the extent you can to their definitions.
Yeah.
Like, their definition, they didn't add axioms. Their definition, their textual definition is kind of all you have. They're going to draw out, they do draw out distinctions that some of which are very easy to see or BFO-like, some of which are not, and some of which require a lot more thought, because some of those are well worked out. It's just not obvious. A lot of those aren't, because they haven't been worked out, and they're kind of like, instead of imposing rich axiomatization that can help them like reason out counter models and stuff, they put it in the text, and so they can't leverage the tooling so easily to check things, and so they have to kind of sit and think about it, and they don't always have time. Like, they're doing a lot of cool work, but because of the lack of axiomatization, they're sort of unable to check any robust consistency, make
What is
any
he talking about?
IES, the Information Exchange Standard. So part of this project 3 is like mapping BFO and IES, but as it's been pointed out, they don't have axioms. So how are you mapping? I think BFO has axioms, and so we draw a bunch of distinctions formally. And if they had those distinctions or like axioms, we could kind of see exactly where they differed from BFO.
Yeah.
They have it in the text. And so now the name is like, the name of the game is like uncovering from their text what logical distinctions they intend. And that's part of the hard work. You can use BFO as a guide, right? Like, we draw disambiguations. Like, when I was reviewing their section of the paper we published, I had BFO in mind. It was helpful for me as a heuristic guy. I was like, there's use mention errors here. Like, there's a confusion over information and representation. That was very valuable. I wasn't saying BFO says, I didn't have to. It was kind of like, don't you think you should draw these distinctions? And if you do, don't you think you should draw them formally? But they, again, for many reasons, I don't want to throw shade on them. I think they're doing cool work. I like them too, personally. They're great people. But they've not gotten to this point. And by the same token, CCO hasn't either. So
are they just a controlled vocabulary?
I mean, they intend to be an ontology. They intend to be constructing.
So they have subclass sub axioms.
They do.
Okay. So they have some they don't have no axioms.
Yeah, they've got some, but nothing like they're not
like what we want to have.
Taxonomies, right? And so because of that, like you only get so much from subclassing, right? Like, you can have some trivial relationships that are probably not going to be tracking the textual definitions, right?
And CCO is like like cooking with a bad cook who doesn't use any spices, right? Like, very little. Like you'll be going through CCO and be like, oh, look, they actually have axiomatization here, and then you'll go, through a lot more CCO and be like, oh, there's no axiomatization.
Yeah, it's like a barren wasteland. Oh.
Yeah.
But so in this project, we're trying to leverage QUDT to enrich CCO, leverage W3C time
We're
ontology.
using QUDT, by the way, where we are. So
I'm gonna go get my charger real quick because my battery's gonna die, and I don't want that to happen. I have no excuse. I'm in Buffalo.
So San, one of the things that John really tried to get us to do in a similar class last year was look at two things. Look at either, hey, if there's axiomatization, is it in the definition? And then two, if it's in the definition, should it be any axiomatization? And so the way that I try to approach things is, if I'm going to assert in the definition, in the genus species definition of something, a relationship with something else, then I need axiomatization, right? Because at the end of the day, you shouldn't rely on an annotation property, right? To
Yeah.
solve all of your logic. And so if I'm going to say that something has integral part of some, I'm going to say, hey, this engine, right, is part of, some type of entity, right? Then I need to have a relationship that says engine is has continuant is continuant part of some entity or something that requires engine. So I think that it's important that like we don't generally under axiomatize to the point where like it's totally useless, because at the end of the day, most of our systems are going to rely on the axiomatization over the annotations.
We hope.
Yeah, I got two, three more short points if it's allowed, but I don't want to take other people's time. And also, one is so if it's weekly, let's let's put it this way. I mean, well, first a small point. I mean, sort of event says it has a starting time. I think that, well, it's reasonable to assume it has a stopping time too now. Just so, but then you're not only adding axioms, you're also sort of filling in the definition. So that's sort of, so you need to go through those motions then in a way.
Right.
So, but because you're sort of then sort of making explicit, sort of implicit assumptions in definitions, in textual definitions, I mean, you don't have a guarantee that this is actually how it's being used. You have sort of a best effort.
Right. Right.
And then it sort of harks back to me, sort of like, yeah, but if it's weak and it's best effort, and we're sort of going to interpret anyway, I mean, why not just, like Joshua said, I mean, go back to the vocabulary, build up the things that we think are reasonably sort of, this is how you meant it. This is how you meant it, right? Just
Yeah.
sort of like within all reason, because why not then just, why try to completely match a weakly axiomatized ontology of which you're going to fill in unsaids,
Sure.
and you're going to make explicit textuals. I'm like, yeah, it feels like almost more an act of domination than of pragmatic mapping. I don't say this right, but
Yeah, I think I actually think it's the other way. So the reason the strategy I pursue is this one rather than to go build it is because they'll never use what I build. They'll never use it. There's no way they'll ever use it. They've already built their thing, and as a practical matter,
yeah,
this history is filled with a bunch of mappings that nobody ever uses. And so in this case, what the plan is to like show them on their own terms, like preaching to the Gentiles in their own tongue and let them fix it. And so we've had much more success doing that. Like the GIST team, like Semantic Arts, like they talked with us, we were doing this, and they were like, you know what, it occurs to us that we have been arguing about what appears to be the distinction between information and independent continuous, and we didn't think of it that way. And so they were like, we actually need to change some things in GIST because this is so much clearer and like illuminated.
yeah.
And
Yeah.
so that's, to me, that's like, it's less a dominate. If it's domination, it's more like a domination by an agreed on logic. Like, don't you like, isn't this a way to do it? As opposed to domination by what, has
Yeah.
traditionally been forceful. Do it or else you're yeah.
It's a wrong wording. What I want to say is like,
I get what you're saying though, like strategically, like
yeah, no, but also because of the strong axiomatization and being very precise, you sort of force people into positions which they probably should have done anyway.
Right.
But it has this aspect of,
Logic, right?
And maybe that is a bit confrontational, but that's
right.
And you need to be very good to do that. That's what I want to say.
Right.
That's a bit the thing. I'm sort of like, hey, I get the logic that if logically you want to get that mapping right, you should go there. But for me, that having kind of finesse and refinement is sort of totally not on my horizon
Right.
now. So
Yeah.
I'm sort of like, and then knowing that there's only one successful mapping, I'm like, no, but I mean, how much should I downgrade sort of, my own ambitions because there is one possible mapping done this way?
Oh no.
Like I'm some of this.
The reason there aren't successful mappings is because the whole like literature on mappings has just been kind of,
Yeah,
to my mind, like directed in the wrong way. They're focused on largely annotation properties. So if you there are maps
yeah,
between like Provo and other
yeah,
ontologies, for example.
yeah,
If you go look at them, they're like in W3C, if I'm not mistaken, and it's like they're like we're gonna take this Provo thing and make it a subclass of Dublin core, blah blah blah. And like there's it's like an annotation essentially. There's no real connection between them. The machine, like machines you leverage can't really do anything with it. It's mostly for humans, right? If you want to say these are mapped, there you go, you can say it. And
yeah,
I could never use that in an engineering context. And so I needed something to use, like I could actually use an application. And so it had me thinking like this whole
yeah,
mapping field is just
yeah. I get
and
it.
part of it is what you're saying, right? It's hard, right? And so me, I'm like, do the hard thing because that's the thing we
Yeah,
need. And we'll find out easier ways to do it as we explore. And
yeah,
that's what we're trying to do here. So, don't take the only one success um like it's too problematic. I think there are reasons to think there are other successes like the provenance ontology BFO mapping.
yeah,
That's, I don't
yeah,
know of anybody that's, I think there are some reasons to think it actually is implemented, but I haven't confirmed it. But I know like that among the community, it's quickly becoming kind of a watershed paper because it highlights this. So many people have come up to me and been like, this paper is changing how I understand mappings. And that's
yeah,
the point. And so I think that I'm
yeah,
encouraged. I think there'd be more literature and more research on this. I think it just needed to be tilted in a different direction. So
yeah. I get it, and it's really also part of the proposition of saying, listen, we know it's possible,
yeah,
sort of, and
yeah,
the fact that it is possible also adds just value back to BFO. It sort of says like, listen, it is possible, and the fact that we don't know how to do it yet is not the right argument to say,
yeah,
is an added value of BFO, which we should not uh, leave unnoted in a way
right.
because nobody does mapping right.
And I think it too, I think that's true. And I think it really gets to the heart of a lot of genuine concerns that people have. So I was in a meeting 2 weeks ago where we were talking about how to orient this contract we have because we had no guidance like on what to do. We just got money and it's like, what now? And so we're sitting around and like we're hearing that sponsors are concerned that mapping everything into this in BFO is going to not play well with other things that they have. And so everybody's like, how do we mitigate this? And I was like, I was the guy who was like, we need to lean into the hard question and just show them that
Yeah,
it doesn't matter. We can map these things and we can do it in a recipe fashion. And I pointed to the paper that Tim took was the lead on the provenance stuff. And that was again, Tim, like, yeah, heck yeah. So but like it was it hopefully I think this contract is going to be geared towards researching how do you actually handle disagreements and domain level ontologies that come from different places. Like how do we reconcile this? How do we kind of automate the construction of mappings so we can
yeah,
play together? But it's all going to be predicated on research like what we're doing here, right? Because that's to
yeah,
me the edge. It's the future. This is the way the mapping community's got ahead if we're going to actually engineer with any of this stuff. So
yeah, got
feel
it.
good about it. But it's getting at that real problem. And it's a problem that's been a thorn in the paw since the beginning of the community. Like,
Yeah,
oh, I want to talk this way. You want to talk that way. What now?
yeah.
I really
So
think you just need to have a division between what you consider things like continuance and what you consider things like processes or occurrence. So if you have some, and it's when those get conflated, or they get collapsed onto each other that we end up having a lot of ontological problems with mapping into things. I mean, wouldn't you agree, John?
Well, I don't want to throw cold water that way, right? Like I think there are many ways to carve the pie. Like IES is a four-dimensionalist structure. Like they don't have the continuous set. They just have the occurrence side. And so what this means is like, as a matter of complexity, you got to put the structure somewhere. They put the structure that we would separate off from continuance and occurrence. They put all that structure on the occurrence side. And so there's a plausible way to say all of the same things that we say. It's just treat them as occurrent. And that's okay. I mean, I think there's some value there. I'm waiting to see, like the details. I think they
They
are.
have no what we would consider continuance. Everything is
Yeah, everything's a
process.
so like chair, like I'm an occurrent, chairs are occurrence, and so this is like a traditional. They consider it a simplification of the graph, right? Like they're like, oh, we just have this one hierarchy, and we can kind of represent everything. As I just said, and I think this is just true. And I think this is becoming clearer and clearer as we talk to them. If you're modeling the same domain, you're going to have to put the complexity somewhere. They just put it under one tree. It doesn't mean it's simpler. I think they recognize that at this point. It's not about who has the simpler graph anymore. Now our conversations are more about like what new information perhaps is highlighted by kind of squishing some things together here and expanding some things out elsewhere. Like, is there new information? And this, to me, that's gold, right? Like that's that thing I was saying last time or a couple of sessions ago where I'm like trained in math. Get stuck on a problem, translate it to another language to see what happens. That's exactly what I think we're doing. And like that's great. To do that work, you have to have the robust mappings, like the translations, because it's hard to do manually. But I really do want that. I want to be able to like squish a graph and unpack a graph and see if anything changes. Like I did do this with like, you don't even have to think of the ontologies, like labeled property graphs. I just want to squish it, unpack it, like translate between them, see what changes. Same mentality, right? We just need the machinery to have more robust semantics so that we can do that in more fine-grained ways. That's how I see us doing this. So again,
Yeah.
Jay, I'm not like I'm always hesitant to, talk about and like especially when I'm processing or comparing against upper level ontologies or mid-level. I'm hesitant to say they're conflating things or there's like something like that because they may be conflating things from my perspective that might not have a negative connotation,
Got it. Sorry for my clunky word choice. I'm sort of I'm a non-native
No, it's
speaker, so I try to express something in a clunky way. My apologies for that.
I have so I put a comment in the chat. It may be relevant for deciding like how far to go with a mapping. And I've noticed that there's really at least two approaches you can take as far as like a mapping being kind of being faithful to what you're mapping in this more descriptive way versus, ideally if you map something to BFO or CCO, you can use that for improving the thing that you're mapping. And it sounds like that's what happened with gist,
yeah.
right? But if you do that, then you're uh, changing the meaning. And the way that I've seen this is with this idea of like a conservative extension. So if you think of the mapping as an extension of the ontology that you're mapping. Or maybe you could think of it really, I guess, either way, you could think of it as an extension of BFO or CCO. Um, and having like there are some ways to check that when you've made this mapping, it doesn't change the meaning of the terms with respect to each ontology that you're mapping. But of course, like that's going to happen to some extent. And so you can kind of define like, well, the example that I thought of was like mapping Provo to BFO. Provo has this thing called an entity and they have a thing called an agent, but those are actually not related to each other in Provo. And so if you were to map, Provo entity to continuant, um, what was the example? Yeah, anyway, this would there are ways that we could have done the mapping which would have changed that relationship between those terms within Provo. And that's I think something that is desirable to not do in a mapping. You don't want to like, I guess you consider it like misinterpreting the ontology that you're mapping on it in its own terms,
Right.
right?
That's
Um,
exactly. So I often think of this distinction as well, because I think of like ontologies formally. And so conservative extensions are they're essentially like you're not like if you take a theory or an ontology and you extend it, you add some stuff to it. You can if you've done it conservatively, you've not effectively not said anything new that the original vocabulary said. Like you've not like glibly logicians, let's say you've not added new stuff to the original vocabulary. You may have added stuff that the vocabulary didn't say anything about. That's fine. Still conservative because you've like conserved the interpretation of the original vocabulary. But if you introduce like changes to the vocabulary, like non-conservative extension, you could like change the reserved vocabulary meaning. You've created a non-conservative extension. This is I think what Tim is getting at. We said you've changed in their own terms what they were saying. Like if I came in and said, every process in BFO has to have an ending. If I like asserted that, I would have changed the meaning of processes, like in BFO's terms. But if I said every process in BFO has to have like, has to have more than two or more than two process parts or something, I've not changed the meaning of process in BFO. This is a conservative extension, unless it's already in the axioms. So it might already be in the axioms, but like that's part of the meaning of process. It like kind of leaves open this unboundedness for the end. It's got to start and it has two parts in here. But that would have already been part of the original theory. So I've not changed the reserved vocabulary process. That's still a conservative change. So I think you're absolutely right. Like when you're doing this mapping, the mapping is cross ontology, ideally, you will not change that reserved vocabulary. You'll not change the meanings of the terms. In that original ontology, you'll try to preserve as much as you can. Sometimes there may be reasons to introduce non-conservative extensions. Depends on your use cases, of course, or depends on whether they've just like you in a sense got them dead to rights, right? Like this is straightforwardly inconsistent. And I think that can actually happen somewhat regularly when you're dealing with ontologies that don't have axioms, right? Because it's logic's hard. It's easy to say something
yeah.
original versions of BFO when I was working on them, like helping build the axiomatizations, like I used automated theorem provers to check things, and I found a bunch of and it was well axiomatized, but nobody had checked it with automated theorem provers. So I found some like kind of wicked axioms in there that I had to exercise, and they had gone unnoticed for years because it was even with the formalism, it's just hard to think about. So it taught me very early on I needed tooling like this. Even as little as BFO is, it's not a very big formal theory. As small as it is, and I'm not bad at logic, you know what I mean? As much time as I spent, even I, like and other people I respect, missed things. So tooling, tooling. But to do that, you got to do the hard work to spell these things out and check them. And yeah, back to your point though, conservative extensions. Like you're
Yeah.
not adding new stuff. Non-conservative, you are changing the reserved vocabulary of the original theory. We try to stick with the first if we can, but sometimes we do get forced into the second. My strategy there is to, as always, I always introduce a new overlay file whenever I'm embellishing a theory anyway, because I'm not trying to mess up even their syntax or their file structures. And then in the second case, if I get to a place where I'm like, listen, check this out, I give them the overlay and I say, I've proven, like, by these premises, you've got something funky. Do you accept these premises? And
Yeah,
usually,
and it seems like it's a good strategy to for sure do the first, a conservative. It's almost like descriptive, right? You're being faithful to what you're mapping. And then, but I can imagine it being a goal actually to maybe reinterpret,
Mhm.
that mapping and be like, oh, these are actually, if you look closely, these are actually related in the way you didn't think of. And, we can actually change that in the mapped ontology.
That's right. That's absolutely right. And I think that happens a lot. And even like it goes the other way, like plenty of times I was thinking about the relationship between Dolce and BFO, and I was like, huh, you know, is like process parthood dissective? Like, it's like an infinite change of descending process parts. Doesn't matter. Should we block it? I think ultimately we did, right? Like, but it's an interesting thing I wouldn't have seen had I not been comparing structures. And yeah.
I think what's challenging for me in this exercise is sort of blue taxonomy wise, it's sort of in evaluating ontology methodology or ontologies amongst themselves.
Yeah.
So you're really one step under sort of recreating new ways of making ontology. You're just under that step almost.
Yeah.
That's why it's sort of stretching.
That's
Yeah.
the plan.
Yeah,
That's the whole plan. Like the old workflows just won't scale. And I
yeah.
cannot, I feel honestly, I feel like this is sincerely, I feel very compelled as an instructor to set the students up in a way that is promising. And so I can't in good faith teach you a strategy I believe will fail to scale and put you partly because I don't want to give us a bad name, partly because I don't want to put you with a skill set that is you could potentially find yourself modeling ontologies the old school way and never even think about another way of doing it. And like never because because I'm not careful enough to tell you about other ways, right? Like, and that would be such a disservice, I think, to you. And I feel very responsible to not let that happen. I want you to have the tools that you can use to succeed and like be able to think creatively about new ways to do things and not, I don't want people coming to church, I want you going and doing cool new work on the edge so that we can automate our way out of this because otherwise, I mean, what the hell? Again, I just can't feel, I don't feel like I could sleep at night if I gave you the wrong tooling. Just don't.
Oh, I got two more short questions. One is this, I mean, so this axiomatization is sort of helps computers to reason with the information that's put under the ontology. But in
Mhm.
in all reality, I mean, if I would have to say, is this a subclass of this or the other way around,
Mhm.
there is seemingly no other way than to add those axioms because it is like sets of axioms. Like, is this a subset of one or the other? I mean, there
Mhm.
is almost no correct way to do it in your head also.
Mhm. Mhm.
Then make it. I mean, if you say we're using logic, I mean, I would have to apply the same logic in my head as I would let the machine apply it. I mean, there's just no space between that, no?
Yeah, yeah. That's right. That's right.
Discussion in a way.
No, this
Yeah,
is right. This is
build
right.
this subclass of that. Yeah, well,
Yeah.
oh, yeah.
So if you
That's not,
I mean, if you get into situations like that, like part of this is not on you, right? Part of this
yeah,
is like on the folks who weren't clear enough, and maybe this, like, if you can genuinely make a justified case that like there is no reason to go. These are like two different graphs and they're equivalent as far as I'm concerned. I cannot distinguish between them because you haven't given me enough resources to distinguish again between them. Bring that. I'm describing the phenomena, and they can say, actually, it's this one. In which case, you're like, well, you better shore up that definition, or they say, I don't care. In which case, why do you have two classes? Like, what does it matter? What work is it doing? Is it a distinction without a difference? In which case, maybe they'll collapse them.
yeah,
Maybe they'll just keep it the way it is and be like, get out of here. Well, how did you get in my house? Stuff like that. Um,
yeah,
yeah, but it really like the descriptive task is what I'm keen on, and I guess I have faith that generally speaking, sport out of the experience that I've had. I have faith that if I describe in the terms of the person I'm talking to, like their own terms, describe well enough some issues that I can show, then like pain of rationality, they're usually like,
yeah,
then it's them accepting it and not me beating them in the head with it. And that's better. Like they get to be an
yeah.
autonomous person who makes the decisions. And I very much want that to be the case. Not just
Either
for,
logic is on the table or it's not. I mean, that's what it's about. No, either logic is on the table or it's not.
yeah, I think that's part, I think that's
It's on
part of
the
it.
table, you gotta
Yeah,
go to mine.
yeah. I think there's truth to that. I even hesitate to say that because sometimes I see architectures and I'm like, there's this totally illogical. There is no logic in this space, but they have reasons for having it that way, and I'm like, okay, I got you. If you ever want to do anything different, let me know. But
Yeah.
sometimes there can be reasons for like chaos, but those are fewer and farther between, I think, than pain of rationality. Like, this is what you said. Did you mean to say that? Is really the next question. Like, maybe you did,
Yeah.
maybe it's up to you. And if you did, okay. But if not, I can show you some ways to fix that. Like, put
Yeah.
this back in, you know?
But once you move to OWL, you basically say logic is in now. I mean, it's sort of
Yeah.
like,
Sorry.
so it's sort of,
That's right. Yeah. Yeah, I agree with that.
yeah.
I love logic, man. You don't have to convince me.
No. I'm not, I'm just
Yeah.
trying to put it politely and no, I'm trying to, how can you have a consistent discussion,
Mhm.
sort of constructive and saying, listen, yeah, and yeah,
It's always about goals.
yeah,
Ultimately, like it's about the goals. And I often focus about the goals. Like, what are you trying to do? What exactly are you trying to do? You'll see if we're ever in like a meeting, sponsor meeting or something. First question I ask is, what are you trying to do? No, and then the next question is, why are you using ontology? There's so many other things you can do. Why are you using this? I just want to know. All right, other questions?
thanks.
I have like a question or
Yes, sir.
comment. So because IES has no axiomatization,
Mhm.
when you're doing the comparisons between BFO to IES, like obviously when you run that script, you're not going to get any pairs. So then it becomes a sort of manual job. But how do you have a way of like checking that these matchings that you're making yourself are like valuable in any way?
Mhm.
And also I was thinking about like um another thing about it not having any axiomatization is like when are you just making IES work in a way of BFO, or are you using BFO to kind of show these problems with IES? Like maybe like when I walked in, you're showing stuff about how like a specific application
Mhm.
ontology didn't have anything for disjointness.
Mhm.
So like the comparison between the two is, I'm assuming they like show things that IES neglects that BFO has built in.
So it's sort of everything you were describing, like is within scope. And so, working backwards, one of that doesn't have axiomatization. And so to get like to pull out on their own terms what they're talking about, kind of do have to look at the textual definitions, and it's like then you have to reason out. You have to think like you're the human. You're like, well, what exactly is the relationship they're trying to assert holds between this class and other things? Because there's something, right? And you know how to put in OWL axioms to like make those connections, and you have to kind of build that up yourself. And then you can use BFO insofar as, and I would encourage you to use BFO insofar as like you know some basic disambiguation to keep in mind. And I honestly think that's really valuable. Like BFO aside, information versus what it's about, like sites for material versus immaterial things. These are confused often. And so you can kind of use those as benchmarks to like check your understanding, type token confusions, like the class versus instance, stuff like that. And then but this isn't really BFO. It's just like just good disambiguating, just good at identifying category mistakes, like just good reasoning. Like I think there's a philosophy plug right there, right? Like we did do this all the time. But then you are really, I mean, I think like, and maybe I'll just say what I would do with this project because I feel like that's where I'm trending into. So let me say what I would do if I encountered this project. I would be working through the textual definition of IES, and I would be adding, just unpacking axioms, adding axioms to capture as much of the textual definitions as I could, like warrantedly could. And I would go through them all as I could and like build up representations, add object properties, create them if I needed to. And then once I've done that, hopefully I've, done justice to their text. I've tried not to go beyond the textual definitions, just try to stick as close as I could with whatever I could justify. Because I would always be thinking, what if Andreas is looking at this owl axiom? Can I defend it? Like I added it because of the text, right? And I would kind of do it piece by piece because I wouldn't assume that they had carefully thought through all the web of logic. And so I kind of would want to do it piece by piece because it's probably some, or maybe something inconsistent there. So I would not be trying to make it consistent. I would be trying to map, like axiomatize each of the definitions on its own terms. And then once I've done that, check it for consistency, as I was saying in the project, but also like run it through to see if there's any map structure in common between BFO. And then I would use that to see if there are equivalencies that I could assert or subclasses I could assert. And I would, if I've done my job well, those are equivalencies or subclass relations that I could defend Andreas and Ian and be like, by your own lights, guys. This is the structure of these things. I added OWL for you, but this is the structure that came out. And I think these are good places for us to look to see if maybe when you have class A and we have class Z, we're actually talking about the same thing in different terms, and that's very valuable. Does that make sense?
Yeah, I think before how I was thinking that the mapping between these two ontologies would be done would simply be like reading an IES definition and being like, oh, I think this is like this in BFO. But I feel like what you're saying is to do axiomatizations based off the textual descriptions. And then from there, when you kind of formalize their definitions, then the comparison could be done.
That's right. And because we want to leverage the machines, and also we like, let's say,
well, that answers my first question.
Okay.
It's going to be like, if you're just like saying something's like something in BFO, that's like arbitrary.
Exactly.
How do you check for
And
that?
that's you don't, like, you just use your intuitions, and that's unfortunately how a lot of the literature plays. And I'm not like, we want to be able to like, one, you want to like, let's say IAS and BFO, where somebody you go through and like do the, oh, this is like that game. And IAS is inconsistent, like logically inconsistent. Well, where? Where in your head were you like, oh, like, oh, these things are incompatible? Like, you're not going to find it, right? Because it's probably hidden, embedded somewhere deep. So we want to use machines to uncover that. And so to do that, we just got to be really careful about the baby steps, fleshing them out and then fleshing out a mapping. And then we also, by the same token, we want to be able to like not just say this is kind of like that, right? There's value there. We definitely need humans to be able to kind of suss stuff out like that, but also want to support that alignment. We want to be able to like leverage machines to be like these walk like a duck, talk like a duck. Maybe this is a duck. We still need to come and say, is it a duck? Because maybe what'll happen is bring it to the team, and IES folks are like, actually, there's some subtle distinction here that we were drawing that is now clearer because we see enough of the formalization around it now, and we see how it's different. We see how it's different from this BFO thing, even if you don't see it, because in BFO, they're kind of, you're not drawing that distinction. We just didn't formalize it. Now we will. That's value add, right? And I want to get to a place where we can have that level of conversation, and we're not going to get there just by talking about whether this thing is like that thing. Just not going to. Logic is too hard for that. We want to use machines to make it easier.
So another question, I guess, is like when you're making these axioms for IES, like, and you want to make relationships between classes and use object properties and stuff, like, are you making your own, or are you pulling stuff out from BFO to make relations?
So usually, so you're talking about the mappings,
Like
between them, or just like adding structure
if I want to add structure to IES
yeah,
because
yeah.
it has a subclass and I want to formalize a definition and the definition has like relationships between entities in it. Are you using like relationships from BFO to relate entities within IES to one another, or are you kind of making your own object properties? Because I feel like
Yeah.
BFO has like its own idea of reality, and you're saying IES uses like a 4D view. So I feel like using their kind of object properties would be uncharitable because there will be discrepancies.
That's right. So
Still relating them to BFO classes, right? So the problem is that if you have a range and domain and you're trying to relate it to something in BFO, you're still going to have an object. So if you want to say this object property has a range and domain of entity to entity, that's not really valuable, right? Because it means you can just have anything between anything.
Sure.
So in a certain essence, you're still going to have to either take a range and domain from something from RO or BFO, or a range and domain from over here in IES. But essentially, if you do the cross mapping, it really isn't more about the object property assertion you're using. It's more about understanding explicitly the range and domain you're even trying to understand. And so that's where it can get confusing. But I don't think that you're limiting yourself by using an you know
I think so. I think
participates in, but I think you have to understand that the whole purpose of a in my understanding, the whole purpose of an object property assertion is really that you're asserting that this thing can have a relationship between things that are from this domain to this range.
But I think what correct me if I'm wrong. I think what Greg's asking about is like, okay, there's a lack of relations or object properties in IES. I'm trying to unpack the logic of the IES taxonomy. How do we do that? We relate classes to classes. They don't have appropriate object properties. What should I do? Should I use BFOs? Because that seems inappropriate. Should I coin new ones? So here's the thing: coin new ones, and based on their textual definitions. Like if they're asserting things are related, they're doing it some way. So you can use kind of a nomenclature that tracks their textual definitions. But also note, like whether BFO or otherwise, there are only so many ways to logically relate things. Like you have the role constraints, reflexive, symmetric. But also you'll have you're kind of that's a limiting factor. It's a strength that you have, but a limiting factor. But also like you can only relate so many classes to other classes. And so there's a finite number of like justified distinct object properties that you can generate. So and if they would have come up with different object properties, that's fine. But like functionally, logically, they're probably just naming them different things, right? So you're sort of doing them a service by like using like just kind of teasing out the logic. So it's not BFO, what I've just described. I didn't describe BFO or anything. What I described is like class to class, role constraints, functional, stuff like that. Like those, and that honestly, that is exactly how I think about on like object properties. I don't think of participates in. I think of relating this occurrent to this independent continuous. And what I think there's like a taxonomy that's connecting things related from here to there, and it has this role constraint. I could do that in a graph, and I think graphically, and I think it helps me when I'm thinking of other ontologies because I'm like there are only a finite number of graphs, and which one do you have? And so that's so again like build your own, right? And then what'll happen is like ideally, if it is the case that some of the ones that you build are like structurally isomorphic to BFO ones, that's something that mapping will show us. And then you'll be like, oh, this is like participates in. Should it be participates in? Should that be the right label? But now you're in a question about the nomenclature. They use a different label. Walks like a duck, talks like a duck. It doesn't matter, right? Label's label.
Yeah.
But machines read the structure, right?
When we use I always like to use participates in because it's an interesting object property assertion because in BFO we're limited
Mhm.
in object property assertions that go between continuance and occurrences. It's a very finite subset that we really have.
Right.
And one thing that like Alan Rutenberg always says, he's like, start with your instances. And then when you realize your instances are the same are similar, they're all RDF type off of a class, right? So if we really think about it, we talk in generalizations of class structures
Mhm.
and universal associations and axioms. But really, what we're trying to do is figure out in reality, inside of our data, how are we making relationships? So if I'm gonna say I have a relationship between John and his cat, I'm gonna say John owns his cat, right? And I'm gonna say, you know what, we're gonna delineate this and say that cat ownership is different than dog ownership. So we're gonna have a separate object property assertion for owning a cat and owning a dog, right? Because maybe owning a cat has certain responsibilities, like, hey, I only need to leave out food once a week, and I need to fill up this water thing that refills. And owning a dog means I got to take him for a walk every day, and there's all these different things that go with owning a dog. Can
Yeah.
owning a cat. Maybe John walks his cat on a leash. I don't
I,
know.
I do not want my cat.
I don't. But my
Like,
point is that you build that out and you build that range of domain out. So then you can reuse that and reuse that. And John was talking about reuse earlier. So if they don't have that, you're building them
mm,
something that's might be very valuable to them. And then if they want to also have these relationships that we have between dogs and cats,
mm,
they might start to see, like John said, some things that are gaps
yeah,
in their structure
right.
so that they can emulate real world situations inside of their graph structures with their data.
Did that answer your question?
Yeah.
Got any more?
This is a less like theoretical question, more so
Mhm.
concerning the assignment, like how much of this do you want, I guess, like how many have you been
Oh, I was gonna let you do that, let you make that decision. I know how much I would do, which
you did
I
the
just
thing.
go through the whole thing, but I understand you guys have other obligations. I don't expect anybody to like kill themselves. Here's what I expect. I expect, to make it through the project and probably do a little more than just like the minimum. But I also expect, and this is one of the reasons, no joke, why I have challenging assignments. I am also looking to see how good you are at time management, how good you are at like not doing too much if you can't. Like, what's your time management process? Like how is the work coming along? So I'll check in with you and I want to hear about the struggles. I want to hear about if like what you're doing in detail, somewhat detailed, although it's not part of the assignment, I'll talk to you about it because at some point, you could go on forever. And I don't want you to do that. You have other obligations. And so that is a skill you learn, you know, and you learn it by habit, like practice and figuring out where that cutoff is. So essentially, boiling this down, I kind of want to use challenges like this to help you identify where your boundaries are because and you're doing it in a safe space because when you're out in the wild, this was talking to Hannah earlier before class started, when you're out in the wild, you don't really, it's easy to get pushed around, like just easy to get pushed around. Going in, like I've been benefited because I was an older like person who had boundaries when I went into like APL, so they ain't pushing me around, like I've got boundaries. But like I've seen people go in there and just get pushed around, and it's all so much harder. Here's a sterile environment where you can kind of identify your boundaries, figure out what you're willing to do and what you're not, and how much time you're willing to spend on something, and kind of comport yourself that way. These challenging exercises are partly to help you learn what those are. Again, I wouldn't be able to sleep at night.
There's also another thing you can do there's another thing you can do that would be very enlightening, I think, for everybody, because I think some of the stuff that John teaches us to do is pretty high level in the community. Take your total file, put it in Grok, because Grok's really like an asshole, and ask Grok how long it took an applied ontologist to build this. And you're going to be shocked at how long Grok thought it took you to build it.
Yeah.
like, oh my God, I did this in 3 hours. It just said it took me a week. And it's because Grok is going against probabilistic, they're using probability with other ontology files, and they suck. And ours are really a lot better in a lot of ways.
It's gonna get better.
Yeah,
Can you ask Grok when the bubble is going to burst, Joshua? Or is that...
What do you mean, when's the bubble going to burst?
Yeah.
On ontology work or on AI?
Oh, an AI. Yeah.
Well, I mean, I think
It was a joke.
I've had experience with this. John's had experience with this. Like right now, I think a lot of AI companies are hitting that trough of disillusion, and they're either going to go bankrupt, stop doing whatever they're doing, remarket into something else that is a line of crap, or they're going to probably call somebody like John Beverly and say, "Hey, do you have really smart people that can help me out of this problem?"
And I'm sending you out.
Yeah.
And if they keep calling, might come to like when the banks start calling. Did you have another question, or would you?
I was just gonna say, my experience this semester is very much forcing me to realize that I have to have good time management skills, because so far, like, I'm still an undergraduate, but I'm taking a few graduate classes, and it's not sustainable the way I'm approaching it, because I'll just work on something one day for like 5 hours and then do it again like a few days in between. Then like it's not working at all. So I know I have to have like a schedule and be really disciplined with myself, and like put restraints on my day and be like, okay, at this time I have to grow up basically.
Yeah.
At this time I have to do this. Like just make a schedule about how I'm gonna get stuff done throughout the week, so it's not like
Good.
Last semester there was somebody who made a BFO like board game, or remember that game we used to play?
Oh, Max Tillis and Greg.
Yeah. What I would do, I don't know who was talking in the classroom.
Greg.
Greg, I would play that game with people, because what you're probably struggling right now with, Greg, is, hold on, I'm going to turn on my so you can see me. Okay. What you're probably struggling with is John is so fast at being able to say like, oh, that's an independent continuant. That's a generically dependent continuant. Oh, that's definitely information content. That's a relational quality, right? And you're struggling with that, right? Because it's hard, right? But I'll tell you, the more and more you do it, I had somebody show me a JSON file Friday, and I was able to look at the JSON file and I just mapped it like in real time. It gets easier and easier, but you got to do it a lot. So I think playing that board game, as silly as that is, that can help you start to speed it up, right? And then once you realize that like we're really just trying to define the who, what, when, where, why, how, and most things that people think aren't actually independent continuants. There, a lot of stuff in data sets is information content, right? So once you start to realize this, it will get easier.
Yeah, I think he might just,
I was more so
correct me.
talking about
Just like the overwhelming class and
School in
graduates
general.
stuff, just like general time man. He's actually really good at.
Oh, that's good.
He's very good at, very fast. He has been for a while.
Time management sucks. It sucks when you get to be my age too,
like the second class I saw you in, like you were like, I remember you correcting people about classification. Like, who is this guy?
Oh, that's good. Man, you gotta be more active in the Slack then. Jeez.
Yeah.
I was more so just talking about my experience this semester with all my classes, how like you were saying, like this assignment and a big part of this class is to teach you time management skills. And I was just saying, like this semester so far, I definitely got hit with the realization, especially this morning. Like I was late because I was working on an assignment for like 5 hours.
It happens.
That I should have done like, that's what I was saying. Like, I just need to be more disciplined with myself and
and also know what's good enough, right? So like in business or in the real world, whatever you want to call it, when there's this idea of like an MVP, right? So it's like what's going to become a viable product, right? So like one thing that I have is I'm trying to take like somebody made all these awesome classes and they're not modularized properly for like modularization because they weren't thinking about that. But we have like 1,000 classes and we have like certain things that are so big you can't even run a Hermit reasoner on them. So I'm gonna have to break them into pieces. But it's like, okay, I need to have consistent deliverables. How do I break that up? Right. So instead of being like, well, I'm gonna take this giant thing and I'm gonna wait a year and a half to deliver it, I might take this small thing and say, hey, this is 1.0. And then in 6 months, deliver 1.1 and one. So like part of it also is like, what is good enough for the assignment for right now, for your customer today, for understanding like, hey, my customer is only tagging data right now. My customer isn't doing agentic AI stuff. Like part of that is going to be like, we're all perfectionists. And it's like, what's good enough for right now?
That's right.
I think you're being too charitable towards me. I'm not a perfectionist. I'm just a procrastinator.
Trying to figure things out. I have like some general advice.
Yeah.
Like that's kind of divorced from the class, but it might be useful. So yeah, I'm a textbook workaholic, so your mileage may vary, but I learned a while back that, we're kind of, and I used to do exactly what you described, like just a day and just focus on one thing. And I would spin my wheels a lot. I noticed to start paying attention to not how I was feeling about what I was doing or like the problem set that I had to solve or something, but more like the output. Like, and so I would kind of almost time myself, like how much am I actually getting done over this hour? And if I couldn't answer that question, then I didn't understand what the hell I was doing. So because I got to always find a criteria for measuring. And so if I found myself, I would just keep in mind as what my progress was through an assignment. And if I found myself slowing down, this is where the textbook workaholic comes in. I would go do a different project and I would just do that again and again and again. And so it was kind of like a little bit, and over time I got this habit of just kind of doing a little bit on this or that every day. And before I know it, it's done. And so I was kind of always ahead of deadlines because I would start early. As soon as I was set, somebody said you had to do something, I would just log it in and do a little bit every day, like maybe sometimes 15 minutes, usually like 30 minutes or something. And I just move on because that was kind of my limit of like, okay, diminishing returns, try something else. My brain would get bored or something.
Yeah.
You might want to take a
Tim's
break.
the anti-procrastinator. You should talk to Tim Coleman. He's the anti-procrastinator.
Yeah.
I know I could do it. It's just like I just have to be more disciplined with myself because like when something isn't when something's just in the back of your head and you're like, oh, this is like a week away, that's plenty of time.
All the time in the world.
Easy to, and then
It's
it'll
like
be
that's
one day before, and instead of doing 1 hour across
Mhm.
7 days, you made yourself do 7 hours in one day.
Yeah.
So
Tim, tell him your secret, Tim.
Yeah, what's your secrets, Tim?
Get everything done as early as possible.
I love it. That's true.
yeah.
Yeah. A week. It's like, as I got older, a week away seemed like less and less a percentage of my overall lifespan. It's like, oh, like if it's a month out, like when I was younger, I was like, I've only been alive for so long. That's such a long
Also,
time.
more variables come up when you're older, right? Like when you're just in college and you just have to worry about like feeding yourself and getting yourself out of bed. But when you have kids and somebody gets sick, you're not expecting these things. So all of a sudden, oh, I had to go to the ER all night last night. I wasn't able to do. So when you get older, you start to realize that like I need to account for all these hidden variables that might happen.
Yeah. There's also, have you heard of this Pomodoro technique where you have like the
Right.
little timer? Mm,
I just thought what I'd start doing is just write myself a schedule and be like,
That's a good first step.
just all right, today you have to do this and this.
Yeah. I found you probably won't always stick with it, but don't let that discourage you because you'll probably also note that if you have a schedule, you get more done, even if you don't follow it exactly than you would if you didn't have one. So I encourage that.
Yeah, I used to have to bill in 15-minute increments and justify every 15 minutes, right? So if you get into the habit of that for like 8 to 10 hours in a day, you start figuring out what what 15 minutes cost you, because if you miss an hour at the end of the day, you're like, darn it, what did I do? I stared off into space, read news, I went to the bathroom, like what? Now you got to cover down. So track a day by 15-minute increments, you'll be a lot more productive.
There's a lot of truth to that. I noticed that when I noticed I did something like this. It wasn't 15-minute increments, but I was just became hyper vigilant about my time. One, I noticed that I could always tell what time it was without a watch. That was cool. Two, I knew exactly what I was doing. And after a while, I got to choose what I was doing. So sometimes I did just want to stare off into space, but I would choose to do it if I wanted to.
I have a friend who's a lawyer, and they've had to be in one firm, it was 6-minute increments. Another firm, it was 3.5-minute increments.
Jeez, they must have been expensive.
It's ridiculous.
Sam has asked the real question, which is how does time management change once we're immortal? It doesn't. Or it does. I might try on all sorts of time management. That's part of the creativity, man. I want to see what it's like to time manage poorly and well.
I just have a really bad track of time too, because like
Set a lot of alarms.
and yeah, no, I'm definitely gonna think about that 15-minute thing.
Yeah,
Like,
yeah, that's good.
oh, like 15 minutes has passed. Like when did
Another thing you can do that some people do. I don't do this. I need to do this. Tim might do this. Is like, so a lot of us in business, we use like Outlook, and you can set your calendar up, block off time in your calendar as meetings, invites to yourself for certain things. So so every day you're going to work on class A from 1 to 1:30, and then you're going to work on class B from 1:30 to 2.
Yeah.
And then you have, if you set it up in the meeting and you have your sound on, you'll actually get a little warning when it's 15 minutes before, and then just if you become really diligent at that, like John said, if especially if you rabbit hole yourself, like that's one thing that Tim has really helped me realize is like, I try not to rabbit hole myself anymore. And what that means is just like we get really interested in something and we go down that rabbit hole deeper and deeper and deeper. And sometimes it's good. Sometimes it's not helping us. Sometimes it's superfluous information that we're putting into, say, an ontology or any subject we're working on. And it's not just the not good enough,
Yeah. Sometimes it's a great way to find new music on YouTube.
That's true.
On this note, I think we're at time.
Hey, John, do you have 5 minutes? You can give me a call.
I'll try.
All right, cool.
5 requests for phone calls.
Right.
But yeah. With that, adieu. It's a pleasure seeing you all.
Yep.
I'll have project 4/midterm out hopefully in the next day or so, and I'll put this video up because I was recording, and I will also record that ontology tradecraft talk that I did in Algebras, which went pretty well, if I do say so myself. So
does YouTube
Cool.
hear me talk about?
I can edit this out if you want.
It's
I'm
fine.
welcome. You're welcome
That'd
to.
be funny.
Okay, I'm gonna put that, like, I'm gonna label the video with that. Greg talks time management. All right, guys.
All right. Thanks a lot.
Good to see you.
Thank you, John.
Mhm.